All right, let's jump right into it. Listen, if you're a developer, you already know the drill. Half your day is spent writing actual code, and the other half, well, it's spent in this blurry haze of constant context switching. You're bouncing between your editor, your terminal, and all tabbing to copy and paste code snippets into various AI chat windows. It's exhausting. But today, we're fundamentally upgrading that workflow. In this explainer, I'm going to act as your mentor, giving you a step-by-step guide to unlocking the agentic capabilities of Claude Code. We're moving way beyond basic chat interfaces, stepping into a world where your tools are actively working inside your environment, right alongside you. We'll be looking strictly at the documentation and source material to get you completely up to speed.
So, here is our roadmap. We'll start by meeting Claude Code. Then we'll unpack the agentic concept, look at executing tasks, managing context, establishing control and errors, and wrap up with shipping faster. Let's get to it.
Section 1. Meet Claude Code and saying goodbye to copy-paste.
Think about the friction you deal with right now. You hit a bug, so you highlight the broken code, copy it, paste it into a browser AI window, type out a whole prompt asking for a fix, wait for it to generate, copy the new code, and paste it back into your editor. It's incredibly tedious, right? Well, step 1 of your new workflow literally eliminates this loop entirely. Claude Code lives where you live. It has direct access to your files, your terminal, and your entire codebase. So instead of you acting as this manual copy-paste middleman shuttling text back and forth, the tool operates directly inside your environment. It's a massive leap in efficiency, mainly because you're finally removing the human bottleneck in that communication layer.
Section 2. The agentic concept and understanding the LLM loop.
Let's ground this industry buzzword for a second. What actually makes this tool an agent? The source material defines an AI agent as software that can interact with its environment and perform actions to complete a defined goal. To use a simple analogy, think of a standard large language model as a brilliantly detailed reference encyclopedia sitting open on your desk. You can look up absolutely anything, sure, but you still have to do the reading, synthesize the info, and actually type it out yourself. An AI agent, on the other hand, is much more like having a highly capable junior developer sitting right next to you. You still have to give it good, clear instructions, but it doesn't just hand you the answer. It has real-time access to your tools, your terminal, and external services to actually implement the solution while you supervise.
So how does this actually play out in practice? We call this the LLM in a loop. Step 1, you give it a prompt, and it reads and understands the relevant parts of your codebase. Step 2, it executes commands and scripts based on what it just learned. But step 3, this is where the absolute magic happens. It uses the output of those commands to decide its very next move. Like, if a test fails, it doesn't just throw up its hands, crash, and wait for you to intervene. It reads the failure stack trace, understands exactly what broke, and iteratively attempts a fix. It's a continuous, autonomous cycle of action and reaction.
Section 3. Executing tasks and real-world applications. Here is where your day-to-day workflow gets a huge speed boost. Imagine you're dealing with a really stubborn memory leak that's just dragging down your application. Instead of hunting it down manually, you simply ask Claude Code to trace the bug. It'll jump in, execute your build scripts, and run your test suite to dynamically isolate the problem. If it realizes a specific dependency is missing while trying to fix that bug, it automatically runs the install command for you. Or, say you need the absolute latest API reference for a new library. It independently steps out to the web, reads the updated docs, and implements the solution. It's doing all the heavy lifting of environment management and dependency wrestling, freeing you up to focus purely on the high-level architecture. Section 4. Managing context and how the working memory functions.
You can think of the context window as Claude's working memory. Now, let's be real here. We all know that dumping an entire 10-year-old enterprise mono repo blindly into an LLM prompt is a recipe for absolute chaos and hallucinations. And this is exactly where the agentic aspect shines. Instead of making you cram every single file into its memory all at once, Claude Code operates strategically. It actually uses commands like grep or ls right inside your terminal to search and find the specific answers it needs, loading only the necessary files into its working memory. It navigates your folders intelligently, exactly like you would when you're hunting down some poorly named utility function. It gathers its context surgically.
Section 5. Control and errors. Establishing guardrails for the real world.
Now, I know what you might be thinking. Handing over terminal access to an AI sounds a little intimidating. You're probably picturing it randomly dropping your production database, right? But the system is built with strict boundaries. By default, before running any command or modifying any file, Claude Code stops and prompts you for an explicit yes or no approval. You hold the keys.
You can choose to be highly hands-on, explicitly approving every single step, line by line, or as you build trust with the tool on a particular task, you can grant it more autonomy. But the authority to actually alter your environment always rests entirely with you.
But just like any tool, Claude Code isn't perfect. The source material warns us directly. It might misunderstand your intent, inadvertently introduce a new bug, or totally over-engineer a complex architecture when a simple one-liner would have been fine. You absolutely must maintain a trust but verify mindset. Remember, you are the senior developer in this relationship. Let the agent do the typing, let it write the code and run the tests, sure, but always review the Git diffs and thoroughly check the logic before you commit anything to your repo. You're managing the intelligence here, not just blindly submitting to it.
Section 6. Shipping faster and integrating into your stack. Ultimately, the goal of all these steps is significantly improving your personal productivity and your delivery speed. And to do that, the tool needs to live natively where you already work. While we've focused heavily on the terminal workflow in this explainer, Claude Code is also available as an integration in Visual Studio Code, JetBrains IDEs, the Claude desktop app, and on the web. You can plug it directly into your tech stack right now and immediately reduce that massive friction between having a great architectural idea and actually shipping the code to make it real.
So, we've covered the vital jump from the old copy-paste cycle to direct environment access. We've defined the continuous agentic loop of reading, executing, and deciding. We've seen how it strategically manages memory through targeted searches and why your explicit oversight through diff reviews is your most important asset. So, I'll leave you with this final thought. Are you ready to hand over terminal access to an AI agent and fundamentally change how you ship code? It is a brand new era for developers, and the tools are just waiting for your command. Thanks for joining me on this explainer.